be more on the machine tool control. So when we talk about the type of the or the component of numerical control, we said the numerical control system consists from three main components. The first is the part program or the instruction of program. The second is the machine control unit or MCU. The third was the machine tool or machine equipment. So this chapter will focus on the third part, which is the machine tool or machine equipment. We are going to talk about the different classification of machines. Then we are going to highlight some of the control system that we use with these machines to control the position, to control the motion of the machine, and so on. So these are the expected outcome of this course. So at the end of this course, you are expected to know more about the specification of CNC machines, classification of CNC machine into various categories, describe the motion control systems. We are going to learn the motion control system and also the interpolation methods. Then we are going to highlight more about the standard type of machine tool that already existing in the shops. Also, we are going to highlight the programming system for positioning. Since we are going to talk about the machines, machine always linked to the motion, to the rotations. So the main part that we are going to control in this machine is the position or the location of the machine, because we are talking about the numerical control machine or computer numerical control machines. So we need to control the position of the heads of this machine, the position of the table of this machine when we are going to, or when we want to produce any product or to shape any metal or to form any shape of the metals or any other materials. So these are the content for this chapter. So we are going to start with the main specification of the machine. Then we will talk about the classification of the machine. So when we say classification, that means we are going to classify the machines based on various parameter or various criteria, not only the type of machines. So we have different type of machine based on specific criteria of classification. Then we are going to talk about some of the machines that using CNC. So just in brief, we are not going in depth to talk about the machine themselves because we are not mechanical engineers. So we are going to highlight some of these machines. Later on, we are going to learn how to program these machines. So in order to program a machine, at least you need to know what is this machine and what this machine is used for. After that, we move to motion control system, interpolation and interpolation method. Then we are going to talk again about the Cartesian coordinate that we already highlight in chapter 1. So we are going to use the Cartesian coordinate here to specify how we can control the position and the path of the machine. Then we are going to highlight some of the fundamentals for programming CNC milling and CNC turnings and so on. Okay. At the end of this chapter, we are going to highlight two main types of loop control, which is open loop and closed loop control of the positioning systems. So machine tools, which is the main title of this chapter, or machine tool control, which is the main title of this chapter. When we say machine tools, we are talking about all tools around us. I mean, in every aspect of our life, in house, in work, in the street, in the factory, in any place, in the market, always we can find the machine tools. So machine tools generally are power-driven machines, that mean machines which is powered or driven by using a power. Any type of power, any type of the input can be converted into machining. Okay. So what is the aim of this machine? For metal cutting, for example, or forming. It's used to metal cutting or forming. Sometimes we focus on metal because if we talk about the CNC machine, it's mostly focused on the metal, but also there is some machine for wood, some machine for PVC, for plastic, and so on. Also the same, they are a machine. But when we focus more on the metal here, because we are going to focus more on the lathe machine, milling machine, and so on. So most of the material that we work on is metal based. Okay, so why we need this machine? For example, to remove chips from this material, or pressing, drawing, shearing, control electrical machining process, and so on. All these they use machine tools. So if we find, I mean, if you see the motor is machine. If you see the servo motor is a machine. If you see stepper motor is a machine, and so on. I think you, I'm not sure if you studied the course for machine. So in the machine we have different type of machine, and it's electrical based, but also there are other machines which are more related to mechanical actions. So these machine tools here are, as we said, used in NC or in CNC machines here as the third component. We said the first component is the program, the second component is the MCU, and the third component is the machine equipment or machine tools. So if I have a lathe machine, so the part which is the third component here will be the lathe engine. If we are talking about the milling machine, so the third part will be the milling. The first part, which is machine control unit, I mean the second part, which is machine control unit, and the first part, which is the part program. So the part program is more on the software, MCU is more on the control, machine itself or machine equipment is the action which we expect as output from the machine itself. Okay, so what is the action that we want to take from this machine, or what is the function of this machine that we are going to run? So when we talk about the CNC machine, we said the CNC, or I mean the CNC machine is represent computer plus numerical control machine, and this numerical control machine usually, or the conventional NC machines, it's operated by using skilled operator. So there is a human or skilled operator who run this machine. But when we have the CNC, the computer come to replace this human by using the software. So usually we have a program inside the computer, and this program will conduct the operation of these NC machines. Okay, so the CNC here overcomes the possibility of human error. Why? Because we are working with a program, with the software. So if the software is correct, all the operation will be correct, or will be more accurate and more reliable than if we depend on human to run the machine, repeated the run of this machine to produce the same product and so on. So these are the main features of the CNC machines here. So the first is accuracy. So the CNC machine over up to negative, less than 0.0001 inch. That means the error in the cutting, for example, or the error in the place of hole that you want to create on the, or to drill to create using the drill, and or to cut using the cutter, and so on, the error will be only up to 0.0001 inch. So very small. But if you use human, or if human want to use the manual measurement and so on, maybe the error will be very high comparing with this ratio. The second, high speed spindle. So the machine can rotate at very high speed, up to more than 20,000 RPM. So imagine that if you want to make a drill, to make a hole, if you want to make to cut and so on, using some of this machine which is rotating at very high speed, this will provide more accurate or more accurate work, and it can produce a very specific type of product based on this high speed. Okay, so instead, if you use manual, for example, if we use manual tool or machine which is running manually, we cannot reach to such high speed of rotation for spindle of these machines. High feed rate drive here up to 600 inch per minute. This is IPM inch per minute, so more than greater than 600 inch per minute. Later on, we are going to talk about the feed rate and also the speed of spindle, and how we can use these two parameters in the calculation of CNC program. Okay. In addition to the three features that we already mentioned in chapter 1, like productivity, repeatability, and also reliability. So all these features can be provided by using a CNC machine. So we can reach to high accurate. When you have accurate, that means your product for sure will be a good product, will be product without any error. Okay, so imagine that, because if you work with these mechanical parts, for example, produce the mechanical parts for machining, for Air Force, for airplane, for train, and so on. These parts should be like very accurate when they cut, very accurate when they put the hole for the bolts, and so on. So they need such CNC machine to reach by using this, by using a computer with the software to control the existing numerical control machines. So now we are going to talk about the CNC classifications. And with the CNC machines classification here, we said we are going to classify the CNC machine based on different aspects or different criteria. So based on the function that means what is the task we want this machine to perform. Okay, so based on the function, this we already talked in chapter 1, we highlight in chapter 1 about this function of CNC machine, and we see some examples for CNC machine. So we can classify the machine into our CNC machine into milling machine, lathe machine, drilling machine, plasma cutter machine, grinder machine, turning machine, and so on. So this all base type of machine depends on what is the function of this machine. So if I ask you classify based on the function, you need to highlight. Don't mention these things. If I said based on the number of axes, you need to highlight this part. If you said based on the motion type, you need to highlight this part. I mean, when we say classify, it's not about the type only. It's not just you mention types. No, you need to highlight based on which criteria. Okay, so this is the based on the function. We have this type of machines. If we said based on the number of axes, also this we mentioned in chapter 1, we said we have 2 axes, 2.5 axes, 3 axes, 4 axes, and 5 axes. So this is based on the number of axes. This is a classification based on the number of axes, and actually according to this number of axes, we need to have this. This some milling machine, for example, the milling machine, for example, depends on. The lathe machine depends on 2 axes, for example. Milling depends on 3 axes, and so on. But also, this is a type of classification based on the number of axes. The third is based on the motion type. Since we are talking about machine means motion, machine means rotation, and so on. So based on the motion type, we have 2 types: point to point or continuous path or contouring system. So the point to point here, that means we are going to talk about the motion. The motion of the machine will be from one point to another point. So the first, for example, the first task will be at this point, the second task will be at that point. So this we call it point to point motion. Or we have paths. So sometimes you have multiple points. So you have from point 1, 2, 3, 4, 5, 6. So this is, we call it continuous path. Later on, we will see the detail about this motion type. The fourth type is based on the control loops. And when we say the control loops, you remember when we talk about the component of the MCU, we said the MCU consists from data processing unit and loop control. So the loop control or the control loop here can be either open loop or closed loop. Later on, we are going to talk about detail about open loop control and closed loop control. Usually for open loop control, we only have the controller. This is controller. Then we have the actuator, and we have the process. This we call it open loop control. Open loop control, that means you have controller or MCU. Then we have actuator. What is actuator here? Actuator is a device which converts energy from electrical into mechanical action. Convert energy from electrical into mechanical action. So the actuator here will get electrical signal from the controller. Then it will convert it into mechanical action, like rotation, for example. Rotation, or like servo motor, stepper motor, hydraulic, pneumatic valve, hydraulic valve, and so on. All these we call them actuators. And these actuators actually are used in the control system in order to perform the action on the processor. So if I want to rotate them, I mean the disk, for example, and they have here actuator is the motor, so the motor will rotate the disk. If the process is temperature, so the actuator here will be a heater, and this heater will increase the temperature or decrease the temperature, for example, and so on. This we call it open loop. The closed loop, we have one more component. We call it the sensor here, and it gives you the feedback. So this will represent the sensor, like temperature sensor, pressure sensor, speed sensor, velocity sensor, the position sensor, and so on, location sensor. So all these type of sensors here give a feedback. It will read the real value or the actual value. Then it will give it feedback to the controller here. So the controller will know what is the set point that I gave and what is the actual value. Then it will do comparison between them in order to adjust the output. So if the actual value is equal to the set point, so it's okay. But if actual value is higher or actual value is lower, so the controller need to take action and send the signal to the actuator, which will convert the signal into mechanical action on the process. So later on, we are going to talk in detail about the open loop and closed loop control for the CNC machines. Then, based on the power supply, and when we talk about power supply here, it's not necessary to be electrical power. This power supply means it can be, the source of the power on the actuators. So this actuator can be electrical actuator. So the signal or the input or this principle of operation depends on electrical. So for example, if we have DC motor or AC motor, this motor you give them voltage and then they will rotate. So this we call it electrical based actuator. Sometimes we have hydraulic actuator. So this hydraulic actuator depends on the power of the fluid. So if we have a liquid, for example, here, which with a high pressure, like the, for example, in the river or in the waterfall and so on. So waterfall will generate a hydraulic power. This hydraulic power will use to rotate some turbine. This turbine, for example, will use to produce energy. So the hydraulic power here, which comes from the force generated by the liquid or fluid, the flow of liquid with a high pressure. So this will generate some of the power to rotate this part. Or we have pneumatic actuator or pneumatic power. So the pneumatic here come from using the air to control some equipment. Like sometimes we have pneumatic valves. So this valve will be open or closed by using control air. We have air with a high pressure like 7 bar, 15 bar, 30 bar, and so on. So this air will be used to open and close the valves. So such type we call it pneumatic. So it depends on the power here that the machine, since we have CNC machine, in the CNC machine we have machine tools. This machine tool used for drilling, for example. So this drill, how this drill is work? Is it take the power from electrical source directly? Is it take the power from a mechanical, hydraulic source? Is it taking the power from pneumatic source? So the rotation of this drill, for example, can come from these three sources, one of these three sources. For that, we classify the CNC machine based on the power supply that used to run this machine or to rotate these machines. So if I have pneumatic, for example, if my device or my machine depends on pneumatic, so in order to rotate this machine, I need to have air with or compressed air. This compressed air, for example, 7 bar, 30 bar, depends on what is the pressure that I require to rotate these machines. The last type of, the last classification type is based on the positioning system. So positioning system here, we said since we have machine, we have motion, we have rotation, we have position. So the machine is not stay at the, when we say machine, that means the machine is not just fixed or stationary. The machine always need to rotate, okay, clockwise or counterclockwise, need to move left or right, up or down. So in this case, we have a positioning system for the CNC machine, and based on this positioning system, we have two types. We have incremental type and we have absolute time. Okay, later on also we are going to talk in details about these two type of positioning system of the CNC machine. Is it clear? The classification of CNC machine and the features.
Yes, sir.
Yes, sir.
Okay, thank you.
Yes, sir.
Okay, 3 answer only. I want 3 answer enough. Okay,
Okay.
continue. Okay, so now we're going to highlight some of, like introduction or overview of some of the existing machining that using CNC. So when we said CNC last time, CNC is equal to computer plus NC machine. NC machine here, we said this NC machine, we have many type of numerical control machines, but these usually were controlled without a computer. They control by using control, the machine control unit, and this machine control unit just like the basic machine control unit, which is the batch, the tape batch and tape batch and reader also for the tape reader batch and to read the program or the part programming for controlling this machine. But when we have CNC, that we add a computer to this numerical control machine. So CNC actually is used for all type of machines. That means any type of NC machine that we have previously in 1960s, it can be controlled by using a computer, by adding a computer. It's from the simplest type to the most complex type. And we already mentioned before, we said some of CNC machines are used to perform one task, but also there is some CNC centers which used to perform multiple tasks. So on the same machine, you can do multiple tasks. Like I can do drilling, I can do milling, I can do cutting by using the same machine. So we call it the CNC machining center. So this CNC machining center, which composed of multiple machine on the same machine or on the same and controlled by the same computer. So there are two common types of these CNC machines or CNC centers, like checking centers, like for example for lathe engine and lathe machine here, and the second one is the machining center. For the checking center here is more related to the two-axis centers. Machines which depends only on two axes. That means only depends on X and Z. So if you have X and Z, so it's only two axes here. Some of machines will use 3 axes or 2.5 axes, 4 axes, 5 axes, and this the axis here or the more than 2 axes will be under the machining center. So the first is the checking center, and checking center has more on the 2 axis machines, and then we have machining center, which is like milling machines and turning machines. So this more on the machines which has more than 2 axes. So here the checking center developed in the mid 1960s, and it's operated on 2 axes. X-axis control the cross motion of the turret head. So we have X-axis which control the motion. For example, if we make it like left, right. So it's just control the motion of the head here, either left or right, for example. Then the second axis, which is Z-axis, control lengthwise travel of the head. So this head, if this is left, right, for example, this will be up, down, or it will be front and back. So depends on the position of the table of the machine from the head. So if the head on the top here, this table can be moved left, right, for example. So this is one axis, and this head can be moved down, up, and this will be the other direction or the other axis. We'll see here in the figure later. Okay. So this is shank or checking center and turning center. This is 2 type. The checking center, which is number A, and the turning center is type number or figure number B. Both are capable for produce round parts. So the parts which is with the round can be produced by using these 2 type of center quickly and accurately. So both are CNC center, depends. Checking center. and turning centers. So as we said, some of these centers used to perform multiple tasks, not only just lathe, for example, or not only milling, not only drilling. It can combine more than 2, 3, 4, machines up to 5 tasks at the same machines. Just we need to modify the program inside the MCU unit here, and we need to adjust some of the tooling or machining here, the heads and so on. Then the machining centers, and the machining center here is more, it has more than 2 axes. It can be 3 axes, it can be 4, 5 axes. So it was developed in 1960s. It's allow more operation to be done on a part of one step instead of moving the machine to the machine. So since you have more axes, so you have more free to move the parts that you want to produce left, right when you use x-axis, towards sway from column here when we use to use y-axis, and also when you use z-axis, it will become vertical movement of spindle. So it can be up or down. Spindle or knee here is the part of the head of the machines, so it can be moved up, down. This can move left, right. This can move front, back. Okay, so it depends on where is the position of the table of the machine. Okay, so this is vertical machining center here. Is used primarily for flat parts when 3-axis machining is required. So this, as we said, it used 3-axis. So this type of machine, we call it vertical because we have another is horizontal. So vertical or horizontal depends on the position of the head of these machines. This some of CNC machines, just to highlight the axis of these machines. So for example, the first is engine lathe. So this is the engine lathe, the normal engine lathe. We have engine lathe without NC, which is manual engine lathe. We have engine lathe with NC control. We have engine lathe with CNC control. So don't be confused, because actually, as we said, it is development, evolution from manual operation to NC operation to CNC operation. Then we go up to until we reach to CAM, CAD and CAM. Okay, so this is, for example, the lathe axis, the lathe machine, and the lathe machine is referring to the first type, which is checking centers. So the lathe machine here is operated in 2 axes. It has x-axis, which is control the cross motion of the cutting tool. As you can see here, this is the x-axis, and here is the cutting tool. So this cutting tool will move this direction for x plus that direction to x minus. So we can move this x-axis, this cutting tool across the x-axis. Then we have the z-axis, which is control the carriage travel toward away of the hitching. So this is the z-axis. You can see here, this is the z-axis. That means this part can be moved to that direction or to that direction. So the operator usually, when this machine is running manually, the operator need to move this part. Go there, push and draw, so it can move this part along the z-axis. That part, which is the cutting part, can be moved along the x-axis. So this is the machining. You can see here the axis here, the axis either z-axis or x-axis, or the position of machine is very important part for the CNC machine. So for that, the programming of this machine, when we talk about the programming of CNC machine, actually it is the programming of the position. We are going to draw the path for the movement. So instead of human hair work to move this part left, right, front, back, there will be a program which will be written by using this G code or N code and so on. So it will use to define how this machine will move either left, right, front, back, up, down, and so on. Okay, so the programming is more on the program of the axis or the Cartesian points of this machine. So the engine lathe here is used to produce round workpiece here held by the work holding. Usually when we have we have a workpiece, so the workpiece cannot live there freely. It should be fixed. There should be some tools which used to fix or to hold this workpiece in the correct place, and then the machine will start to move in order to perform the lathe action on this machine. So will be like there is a revolving valve or revolved valve spindle which used to cut or to drill this product or workpiece. These some of the existing turning centers, which and the turning center here is actually it is a lathe with a computer. That means this is the lathe machine or the lathe engine. This was the manually operated or NC operated engine lathe, but this one which was more with the computerized or with the computer, which is a CNC, and we call it turning center. So the turning here is the act of cutting a part on the lathe. So if I have a part or a workpiece I want to cut, so and I use the turning center here in order to cut this piece by using a turning center, or which consists of the lathe engine plus the computers. Machine using CNC for drill press here. So this sub drill, we know the manual drill that we use actually to make drill on the wall or on the wood or on sometimes on the plastic and so on. But for the machines, it's more, or the big machine or to drill some big parts or some metal products. So we need to use such drilling machines, which here is the vertical type of drilling machines, and it's provided with the controlling unit here. So the function of drill here process is to grip and revolve cutting tool. Usually this cutting tool we call it twist drill. So the twist drill here, which will be used to drill some bars, usually it's replaced or there is different type or different size of this twist drill, so that the hole can be produced in a piece of metal or other materials. So usually the drill is used to create the hole. So this hole actually will be created by using a twist drill. So as we said, drill here can be replaced because there's different type and different size of this twist. Milling machines. We said milling machine is referred to the third type or the second type, which is the machining center. And the machining center here, it uses 3 axes. So we have X and Y and Z. So the X, as we already mentioned before, we said X will control the table movements left or right. So if this one is the X axis, so this is to the left, for example, this one is this direction to the right. Then the y-axis here will control the table movement towards or away from the column. This is the place, or this is here the head. If I want to make the piece under the head of the machining here, I need to push this into the negative y direction. If I want to remove it from the place of the machining here, I can draw it to the other direction. So to either toward, away, or away from the column of operation here. The Z here direction will be up or down. So we have up and down. So this will be, if I want to, if the piece here or the work or the metal or the piece that I want to modify or to cut or to make a hole is existing in this area. So when this tool is moving along the Z axis, it can go down until touch this metal or this piece. Then when I finish, it will go up far away from this piece. So this is why we need 3 directions. So Z axis control the vertical movement of the knee or spindle. So the spindle can be go close to the material that I want to shape or I want to produce, or can go away from this material that I'm going to produce. So X, Y, Z, which is the 3 direction. And we said previously, we said some of machines, it has 4 directions, 4 axes or 5 axes. Also, we need to use more than one axis. I mean, or rotational axis across Y or across X or across Z, depends on what is the type of the machine. So this is the CNC milling machines. So the horizontal milling machine here, there is two types, horizontal and vertical milling machine are the most common type. So, and we said the horizontal or vertical depends on the place of the spindle here. For example, this is a horizontal, and if the place of the spindle on the top, so this is a vertical. Both machines use one or more rotating milling cutters. So they are cutters, which is or rotating cutter, not normal cutters. The normal cutter, that means it's stationary, but here it is a rotating cutter, which having a single or multiple cutting edge, depends on the required task that we will need to perform. Milling machine are capable of performing wide variety of operation. As we said before, milling machine is referred to the second type of centers, which is the machining centers. So it can, I mean, it can also use for drilling, for reaming, boring, and also spot facing. I mean, as we said before, maybe one machine or one center can be used to perform multiple operations, not only specific for a single operation. This is the grinding machines. Also, the grinding machine can use for, I mean, the cutting tool here to bring a workpiece accurate size and produce a high surface finish. So usually we use the grinders or the rotating wheel with the cutter. So this rotating wheel with the cutter will be used to cut some part of the surface to make a nice shape for the surface, to make it more smooth and so on. Depends on what is the required task we need to perform.